Okay, let's look at how to do a boiling point elevation problem. Right, so the first thing that you would need to know about the boiling point elevation is the formula. So it's kind of like the freezing point depression. It just goes change in temperature boiling equals I KB and then little m. So this again is the change in temperature. I is the Vant Hoff factor. KB is the boiling point elevation constant, and little m is the molality. So it's just like the freezing point depression problem. There's just a couple of little differences. Okay, so the first thing is if it says what is the boiling point, that means to begin with we're going to solve for the change in temperature boiling. So we have to get the Vant Hoff factor. You get it the same way that you got it for the freezing point depression problem. So you would go BaOH2 is barium hydroxide. So when you put solid barium hydroxide in water, it's going to dissociate into barium ions and hydroxide ions. But you need 2 hydroxides for every 1 barium. So that's what it would do when you put it in water. So the Vant Hoff factor, remember, is the I. Okay, so you add together, okay, the number of moles in front. If there's no number, remember that's 1. So 1 plus 2 is 3. So in this case, our Vant Hoff factor is 3. So we're going to plug that in right here. All right, we're going to multiply that times the boiling point. It's sometimes called the molal boiling point elevation constant, but it's KB is what they show it as in the book anyway. And so if you look that up, so KB for water anyway is this number right here, and you will be given that on the test. So it's 0.512 degrees Celsius over molality are the units. So degrees Celsius over molality. Now we need to multiply that times the molality. Okay, so remember that molality is equal to moles over kilograms. Okay, we don't have moles though, we have grams. So what we have to do is we have to change the grams of barium hydroxide using the molar mass into moles. So for every 1 mole of barium hydroxide, if you add up the molar mass, it rounds up to about 171 grams of barium hydroxide. That's the molar mass. And so if you do that, that gives you about 0.27 moles. So if we're trying to do this molality formula, okay, we're going to take 0.27 moles, then we have to divide that by the kilograms of solvent. Remember, if you're in milliliters, you can change to kilograms by moving the decimal 3 spots. Okay, so that's going to be 0.85 kilograms. And so when you take 0.27 divided by 0.85, I'm kind of running out of room right here, but that's going to equal around 0.31 little m. So I'm going to take that molality and I'm going to plug it in right here, 0.31 little m. So now I'm going to multiply 3 times 0.5112 times 0.31. Notice the molalities cancel and you get degrees Celsius. So the change in temperature boiling, if you do all this math, it's going to equal around 0.48 degrees Celsius. Now you have to memorize the boiling point of water. The boiling point of water is 100 degrees Celsius. But this calculation that we just did said that when we put this compound in water, it's going to elevate its boiling point by 0.48 degrees Celsius. So what you have to do is you have to take this 100 degrees Celsius and you have to add 0.48 to it. And so the temperature at which this water would boil with this barium hydroxide in it is 100.48 degrees Celsius. That would be your answer. All right. So to review, number 1, you're going to write down the boiling point elevation formula. Okay. 2, you can get the Vant Hoff factor by writing the dissociation equation, adding up the moles of ions. 2 plus 1 is 3. Okay? So that's how you get the Van Hoff factor. Kb will be given to you on a test or on a worksheet, or you could Google it for whatever substance. Now water's is 0.512 degrees Celsius over little m, but if you had a different substance, it would have a different Kb. So make sure you use whichever one you're given. Then you have to calculate the molality. Okay? So to calculate the molality, okay, would be the fourth thing that you'd want to do. And to get that, you're going to take the moles over the kilograms. So you take the moles that you get, you can get that by changing the grams to moles, and then dividing that by the kilograms. Then you plug it all in, and you get the change in temperature boiling. Okay, so after you plug it all in, you'll get the change in temperature boiling, and then the last thing that you want to do is add your change in temperature, which I forgot to put degrees Celsius there, but you add that change in temperature to your original boiling point. And so 100 plus 0.48, so it'd be 100.48. Now on this, we're not really worrying about significant digits because we're saying that the boiling point of water is exactly 100 degrees Celsius. And so we're just going to add the 0.48 to it. So it ends up being 100.48. All right, that's it with that video right there. So you might have to go back and look it over, see how it all works.